Hi guys, here's me working on this drill charger circuitry again. I've just quickly thrown together what's going to be a prototype module in a box just to prove a point that it functions more than anything. So what we've got here is this charging circuitry. So this module where you set voltage, current and current limits as well. I've got a little 3-segment meter here. Just glue gunned that in there. I broke the case when cutting this, but again it's just a prototype to prove a point. So I consider these sort of 30p cases disposable testers. And we've got these XT60s on the input and output. So that's the standard circuit we've got set here. So I'm going to so here is the battery that I've just made up today. If I plug that into the output connector on the charger block here, it will read a voltage. So it's currently showing as 16.6. So it's just giving me an indication as to the voltage there. So if I take that off again, so I've left this open circuit at the moment, just so I can do some current measuring as well. So what I'm going to do is plug in the power supply for this. So the power supply that I'm using is a Dell laptop charger. This one happens to be a PA190002D. The voltage on this one is 19.5 volts at 4.6 amps. So it's basically, let's call it 5 amps and let's call it 20 volts. So it's about 100 watts. So, you know, something in that area, about 90 to 100 watts. So I'm going to plug that into the wall now. So that's plugged into the wall. Again, as a prototype, I've just quickly thrown this together. I've not bothered to do too much in the way of heat shrinking or anything. I will do when it comes to the final product. Here's my voltmeter. And I'm going to measure the voltage across the output here. It's come up as 19.57. So that's 19.57 across the output. If I plug this into the board here, and connect this across, which is easier said than done. Notice the output is currently set to 15.5 volts. You can see it there on that circuit there. So what I need to do is adjust the trimmer here to put that up to the 4 at 4.2. So that's going to be, what, 16.8 volts? So I believe on this module that the voltage is controlled by this trimmer here. So I'm just going to try to get into that slot there. That's fine, that's it got there. So I'm going to set that for 16.8 out. I'm also going to try, wee nice big sparks there as we're feeding the switcher. I'll need to get something to hold that closed. Okay, so here's a quick test circuit I've thrown together. So I've got my voltage input coming in on this lead down here. I've got a break in the circuit here so I can measure the current fed through the unit. Instead of the battery, I've plugged in this 12 volt 10 watt lamp. So that's going to take, give or take, an amp. And we will now be able to measure the voltage and the current, I should say. So if I so the voltage across the lamp is going to be shown here because this is shorted directly across the output. So if I temporarily connect that, you'll see we're getting 13.8 volts there, and we're getting quite a lot of light. So 13.8 volts would suggest that we've got Probably well in excess of an amp. I think we're probably overloading the LED at that. So I'm just going to turn that over so you won't be blinded by it. I'm just going to measure the current here. So the current is measuring as 1.25 amps at the moment. So I'm going to take this circuit here and try to work out which one of these pots is the main current limiter. Right, so it's that one. So the pot on the end appears to be the one that sets the current. So we've now got 13.8 volts, so I've got 13 watts going into this LED at the moment, which is still relatively cool. I mean, the heatsink doesn't have any temperature about it yet at all. So this circuit is basically generating 1 amp. So it's crawling down slightly as this circuit heats up. There's no measurable heat there. So that's we got that set to 1 amp as the constant feed. So if I take that off the output and measure the current again, we've got 28 milliamps. Notice the voltage is set to 16.8, which is what's required for the 4 lithium-ion batteries in series. So if I take that load away now, put the battery across the output and measure the current now, we know that we're not going to get more than that amp, because that's the amp. Okay, so I've just adjusted this middle potentiometer. That's the one that sets the low current cutoff. So if I adjust that, turn that back up again, you'll see that this LED changes. It's in my hand there. You see it's gone to the red LED now. Let me just turn that light away so you can see better. And in fact, let me just move the camera. Okay, so we've now got this multimeter in circuit here showing the current being fed to the circuit here. The battery is being charged as we speak. The battery voltage is measuring 16.8 as we see here, so it's literally right at the point where it's considering itself fully charged. Excuse me, I'm just fluttering on the connection there. It was causing this to cycle a bit there. So you'll see here it's got 163 milliamps and it still thinks it's charging, which is fine for me at this stage. I really need to sort out this connection a little bit better, don't I? Need to get my little clip probes out at some point if this keeps happening. So you'll see here we've got 168 milliamp flowing through as the battery is topping itself up. I think I'm going to let that continue to go, and I'll set this middle potentiometer so that when the current gets below 100 milliamps, that's considered full. So we'll stop the video just now and we'll come back when that. So I've changed over to the milliamps range on the multimeter now, and you'll notice the current is dropping. So it's getting down to about 140 or so milliamps at the moment. We'll continue to let that go until, as I say, we see under 100 milliamps. That will mean that the circuit will mark it, or the circuit will be flagged up as charge complete as soon as the circuit's drawing, or the battery's drawing less than 100 milliamps. So that's a good sort of point, really. Ideally, these batteries would want to have a trigger point to actually switch off the charge. I may try to put a circuit in place to do that at some point, but again, this is just an up and running prototype to just get moving. What I may do is actually use the LED in here as a way of self-triggering. So when the charge LED goes out, it actually removes the power using a MOSFET. So that would disconnect the charger entirely when the power went off. So that's me fluttering on the connections again. Right, you'll see here it's starting to consider dropping into a charge state. The LEDs are going slightly crazy down there. Let me just turn the light away for a second so you can see what they're up to. So you'll see the blue light is basically the I'm charging normally, and the red light is charged. And we're beginning to get to that sort of point. And the output voltage across the battery is still marked as 16.8 volts. So we're now down to 116 milliamps. So I'm just going to adjust this preset in here. And I'm going to adjust it until, see right there, it's at that point where it's half and half. So it's right about there I want the pot to be sat. So I'm just going to move it slightly that way so the charge current will be lower before it drops out. So I now know that if I'm watching it live, when both of these lights are on, we're in the area of 100 milliamps. So that was me on the connection again. So I think that is going to work as a circuit to ensure that the voltage drops off, the current also drops off, and that the batteries will charge but not overcharge. See, that's us crossing, the light's getting more red than it is blue now, and that's me just at 100 milliamps. Let me just adjust that a touch again. Just pushing it slightly more towards the, I want that blue light to stay on until we're at the 100 milliamps. And that's pretty much spot on there. It's starting to try to drift back to the red. So the red is slowly coming on there at 104 milliamps. And the red's pretty confident by about 102. And we're at that flutter point at 100 milliamps. And we're pretty much solid red by 100, and we are at 100 milliamps solid red. So that to me is basically the final settings that we need for the power. So I'm just going to reset here. I'm going to solder the wire straight on so that I don't have a current tap anymore, and see what happens. Actually, just before I do that, I'm going to put the LED back on and just check that my maximum current hasn't been adjusted too badly here. So before I blow the fuse in my multimeter, I'm going to change the lead over to the amps. That's me now in the 10 amps section on the multimeter, and we're now measuring what would be equivalent to a maximum charge current of basically an amp. So I tweak that just ever so slightly. I want that to be fairly consistent amp, so wherever possible. So I'm going to try to adjust that just slightly on the high side, so that I know that, because these batteries will take a half capacity charge. So I'm going to set that to a 1.2 amp charge. circuit's still dead cold, so that's fine. I think we're going to leave that at that and see how things get on. Let's just quickly tap back onto the battery again. So we're measuring 16.7 off charge, and when the charge is added again, we see a charge current of 100 milliamps. And as far as the LED is concerned, that's us solidly in the charged world. I think that's us really for the moment. That's the prototype sort of proven to generally operate and generally work. Time to just tidy this up and put it into practice. Let me just measure the voltage across the battery just finally. Because I know here it's marked as 16.7 something. So it's on an uncalibrated meter here as well. So I'm just going to measure the actual battery. So 16.81. Divide that by the 4 cells. That's 4.2 volts per cell, which is the cutoff voltage for a lithium ion cell. So to me that looks like a successful project. I'm just going to connect up that charger and see what happens to the voltage. So it raises extremely slightly while it's on charge, but that should drop, shouldn't go much further, if at all any. So, looks good. I think we'll go with that as a circuit and call this prototype made and test. Thanks very much for watching. If you've enjoyed this video or have any comments to make on the quality in this type, please feel free to subscribe, comment. All your comments are appreciated. Thanks for watching. Have a good day.